Welcome back to this little series I'm making again about how computers really work and the logic behind a computer system so you can see how it works. As always, this program is free by this other creator named Sebastian, and then we're going to talk about the program counter today and how you can make a program counter and then what its use is really in the CPU. Even though we won't really be utilizing its function just quite yet because we're not quite there, I still want to go over to see how it works. So the core component in the program counter is the JK flip-flop. So just give me a second to set it up. And so if you remember in the JK flip-flop, if J and K are both on, and then you clock, and then you hit the clock button, or you pulse the clock, the two outputs flip-flop, and they flip-flop at half the rate of the clock. So if we align a whole bunch of these up in series together, we get this counter sort of thing, which we can use for our program counter with a decoder at the end. Okay, so this is it. This is how it works with the JK flip-flops all lined up together in series. So every time we pulse the clock, we're essentially just flipping these output numbers in order to make this type of counter thing. So as you can see, when we pulse it, we're just incrementing the current number by 1. And then if we sync this up with the clock, we can get this program counter to let us know that right now we are currently on program 9. And then if we flip it again, now we're in program 10. And then if we flip it again, we're on 11. So now we just need a decoder to decode this binary output into these 16 single outputs so we can essentially make it do a function whenever that certain output is on. Okay, so this is the decoder that we made for our program counter with the JK flip-flops that we're about to use. And I mean, this circuit might look a little intimidating, but basically all we're doing is if the 4-bit input equals a number and we're using AND gates to the side, if it equals a number, then that number lights up. For example, so if it's 8, the 8 one's going to light up. If it's 9, 9, and so on. 2, so that's how we're gonna decode what the JK flip-flop output is into what program number we should be on. So we're gonna say that 4-bit to 16-bit. And then every time we pulse the clock, just like this, it increments by 1. So that's how we're going to decide what program you're on based on the clock pulses. So yeah, this video shouldn't have been that long. But this is how our program counter is going to work, and we're not going to use it right now in our CPU because we have no programs to count, because we need to code them first. But we still have more work we need to do with it before we can add our custom programs in, like make the GPU for CPU and so on. And that's going to exactly be the next video, which is the GPU. But yeah. So that's it. See you.